Hi, welcome to Module 6. This is a part 5. We're going to talk about active flat plate collectors. And so this is our flat plate collector heating system. These are products that I'm purchasing. Your typical flat plate collector is built on a metal box style with some type of plexiglass or glass covered sheeting with a high thermal capacity opaque black glass on the front. It allows us to transmit heat. If for some reason there seems to be an issue with your flat plate collector, oftentimes what's happened is that the tubes that are running the water or the fluid, if it's just a fluid slurry, like in our climate, we might buy a product that has a non-toxic fluid inside that is got an antifreeze so that it does not freeze in our collector system, and it goes through thermal contact within our hot water heater within our building. But if I'm finding a lot of inconsistency, what's happened is the tubing has lifted off the insulator plate. And so that's one of the places where I'll see efficiency go way, way down if for some reason those two things lift off of one another. Here is an example of the mounting of a solar hot water heater system. Here is the interior box structure. And then here's some arrangements. And because this is a product that is purchased, there is a lot of different product versions that are out there. And so we have the serpentine parallel tube. This is the tube form in sheeting and the trickle type. Serpentine and parallel tube are tube structures that are running on top of that insulator plate with an opaque glass on top of that, within a thermal box, a box that has good insulation structure. It has an intake valve at the bottom where I'm sending the cold water in, and an outtake valve at the top where I'm pulling the hot water out. It works on twofold of the pressure running through the lines in the glass, as well as siphoning off hot water that's rising within the water itself in the tube. Some images. Flat plate collector. This one is going to a hot water heater. Here's a corrugated. Corrugated is a surface run system where I'm actually just running the water down the corrugated sheeting, which allows it to heat. This is something that works really well in tropical climates and also doesn't require a lot of work or money. It goes all the way back to one of the earlier module videos that you watched in part 6, where I showed you the aqueduct system with the piping, the copper piping that ran inside, and I said this is one of the ways that we could heat water. This is another way I could heat water and create also a really attractive water feature. Which brings me to the newest version of hot water heating on the street, which is the EVAC tube. Now, there is a demo EVAC tube system that is located in the quad in the tech building of WCC's campus. And so if you are walking through the tech building, look in the center of the quad, and you'll see this funky tubule structure black things out there. Those are EVAC tubes. That's a hot water heater system. Here are some examples of EVAC tubes, and they are a tube-in-tube structure where we send the cold water down and into the structure. It allows the hot water to raise up because it is less dense, and then I siphon the hot water off the top. So I'm basically syringing in the cold water to the base of the tube and allow hot water to rise to the top. They are pretty efficient at heating up your water. They do a really good job, but they're incredibly delicate, and a lot of things can change their ability to create thermal capacity within themselves pretty quickly. So slight loosening. Here's a picture of an EVAC tube structure in a demo model at some workshop. Taking pictures. I take pictures of everything. This is a solar plate flat collector that is a closed loop system, and it's closed loop because it's a fluid that is being run through its tube lines, and it just keeps running through the fluid structure here, and it goes in thermal contact with the water, but it does not actually mingle with the water. So the tube is heating through the tube structure, so through the copper itself, it's heating through it to the water, right? So I'm in thermal contact, but I'm not in physical contact, where the fluid in the line is touching the water in the box. And this is important. This is one of the systems that you would buy or use in our climate type up in New York, we would want to use something like this where we wouldn't have to try to drain the system or worry about it freezing or cracking in the winter months. So on that note, we've come full circle on our modules, and I know that this is parts. There's a lot of parts to this, but it's twofold. Passive solar, there's not a lot of clean videos in, and the book doesn't do a very thorough job at showing you the newest, current, most knowledgeable technologies. And so while they're touching on subjects, I really wanted to spend the time and go into it and show you where the technology is headed. It's one of the things that is very near and dear to my heart because they are passive systems. It allows us to really take advantage of the sunlight without having to do a lot, and you can do so much. So on that note, please review as needed the parts of the video that you need to know and work for you. If you have any questions, once again, always post in the discussions. I will be checking every 24 hours within this module set. And I look forward to picking up with Module 7. We're going to start talking about solar panels, so actual electrical generation. So we're going to take in, instead of talking about heat, we're going to talk about electricity, which is fun stuff. So looking forward to moving on, and good luck getting your work done.